Okay. Thank you, Archana, for the introduction. Good afternoon, everyone. So, welcome to all participants, and thank you for your time for being present in this webinar. So, today's webinar is on optimal NDT techniques for inspection precisions and overview of NDT, advanced NDT and NDT techniques. So, purpose of this presentation is to provide overview of non-destructive testing methods, specific focus on their precisions and recent advancement in non-destructive testing. So we will explore conventional NDT techniques and highlights that advanced NDT technologies in this session. So after this webinar, you will have a clear understanding about NDT techniques, their basic principles and applications, and how these advanced technologies are shaping the industries and pushing the boundaries of inspection technology. So left hand side, you will see that there are 12 basic NDT methods. These are the basic NDT methods, but you will have the techniques in each and every NDT methods.
Yes, sir.
Suppose.
Yes. Sorry to interrupt you, but please unmute on Teams, because on Teams participants are not able to hear you.
Teams.
Please unmute on Teams.
And now it's clear on team side.
Yes, now you are audible.
Okay, now it is clear from team side as well.
Yes, sir. Now you are audible.
Okay. Sorry for the interruption. So we are discussing that there are 12 basic NDT methods in which each and every methods there are techniques available. For example, if we are discussing ultrasonic testing, there are techniques available for thickness measurement, PAUT, TOFD, then angle beam scanning, and etc. Immersion scanning, we can say. So each and every method have different techniques. So we will see the techniques and the basic principles of different NDT methods. So first of all, I will explain non-destructive testing, what is NDT and DT, and difference between that. Non-destructive testing, as you all know, we have to check the components integrity or soundness by the use of machines, non-destructive testing equipments at site only. But in a destructive testing case, we have to cut the samples from the location and we have to send the samples at laboratory for analysis. For example, hardness measurement, impact test, bend test, and well sample WBS PQR check test. We have to send all the samples at destructive analysis for laboratory. But in non-destructive testing, we can use this testing at component only and without destroying the component and its integrity. So these are basic destructive testing setups like scanning electron microscopy, crypt testing equipment, optical microscopy. We have to check microstructure analysis, then optical microscopy is used, then hardness, UTS, and if image analysis, we have to do different phases characterization, we will use this image analysis software. And these are non-destructive testing. We can use these techniques at site only. So these are the techniques: thickness measurement, PAUT, hardness measurement at site, in situ metallography, magnetic particle inspection, and ultrasonic flow detection. So as I have mentioned, in each and every methods, there are techniques. So this is the basic technique, visual examination, in which there are two methods. First is the direct visual examination that we see with our eyes and with illumination. And another is remote visual examination, where the access not possible. We are using that remote visual examination technique by use of boroscope and endoscope. Similarly, for penetrant testing, water washable, visible and fluorescent, and then solvent removable, visible and fluorescent. There are more techniques are also there that we will discuss in penetrant testing section. Similarly, like in magnetic particle testing, dry and wet particles inspection, then visible fluorescent, there are two methods. Then type of machines we are using for magnetizing the component, that is yoke, prod, coils, and central conductor. Then type of current also, if we have to check the surface defect only, then we will use AC current. But if we have to near surface defect inspection, we will use DC as well as HWDC current. Then this already I have explained in first slide, that ultrasonic testing having different methods, having different techniques like angle beam scanning, QFD, PAUT, thickness gauging, etc. For eddy current, inside and outside tube testing, which is used for heat exchanger inspection. Then flow detection and sorting. Remote field eddy current, generally used for ferromagnetic tube pipes. Then conductivity measurement and sorting the material by eddy current testing. These are the techniques. So now the importance of NDT in industries. First is ensuring safety and reliability. How we can ensure safety and reliability? By detecting the NDT, by detecting the flows at early stage by NDT, non-destructive testing. And by this method, we can prevent the catastrophic failures in the industry. Then enhance quality assurance by the use of different codes and standard. We can prevent rework or recall in the manufacturing stage. Then asset integrity management, that is very much popular nowadays for plant inspection, plant component integrity inspection. Then minimize environmental impact, that we can do by the hazardous, before leakage, the hazardous material to the environment. By the use of NDT, we can detect, and that by that method, we can minimize the environmental impact. So if effective non-destructive testing not used in the industry, one can identify explosion and accidents, and also unplanned shutdowns. Suppose if tube is leakage in the boiler, unplanned shutdown taken place, and entire system of the plant will stop. So this is the non-destructive testing capability. It will detect defects in any orientation. We can identify defects and sizing that defect, and based on that, we can analyze this defect, whether it is acceptable or not acceptable. If it is not acceptable, we can do the rework on these unacceptable flows. Then NDT can be used during manufacturing. Suppose right side you see the photograph of root weld pass. So by DPT, we can check the root pass welding integrity. If any cracks are there, we can remove the root pass and again welding. If it is clear, we will do welding in the final welding. In manufacturing stage, after manufacturing, we can use different NDTs by checking suck seam, long seam, and nozzle joints of the pressure vessels. And in service inspection, you all know that plant component, we are checking thickness measurement, flow detection in suck seam and long seam joints, and all other inspection, visual inspection, thickness measurement, then internal oxide scale in boiler tube analysis. During operation, NDT inspection can be used to assess current damage state of equipment, monitor damage mechanism, and make informed decision for remaining equipment life for evaluation. By thickness measurement, we can identify the corrosion rate, and by that way, we can identify the remaining life of the component and piping. And if any action required for repair, we can take immediate action on that. So the benefits of non-destructive testing, every large portion or material can be examined. See the right side in the photograph. The person is using equipment and scanner, full well volume inspected in the big pressure vessel. So material can be examined for condition of internal as well as external. We can take internal inspection permission and vessel entry. Then we can identify internal as well as outer surface flaws and defect. Parts can be examined while in service. We can also we have technologies available. For example, high temperature thickness gauging probe or high temperature probes are available for weld scanning. And then acoustic emission testing, we can use this technology in in-service inspection. So many NDT methods are portable and can be taken to the object to examine. So simple equipments are there in the non-destructive testing. We can take this equipment to the component and inspect the entire equipment. So the advantage: flow detection and evaluation, leak detection in the component, location determination and orientation of the defect. By the use of, for example, we will use the surface NDT technique. We can identify the surface and subsurface defects. But if we have to identify the beneath the surface defect, we are using ultrasonic flow detection and radiography testing. Then dimension measurement. If suppose the pressure part or any component which is in creep zone, we have to measure the outer diameter of the that component, or we have to perform in situ metallography. So that we can do at site only. So structure and microstructure characterization by that way, and material sorting and chemical composition by use of PMI and eddy current testing. We can sort the material, ferromagnetic, non-ferromagnetic. Like we can identify the chemical composition also, whether it is 314, 316 or carbon steel. So the conventional NDT techniques overview. Very basic NDT techniques for subsurface and surface NDT evaluation. First is visual examination. As I said earlier, visual examination having two techniques: direct visual examination, which is a primary NDT method. A simple visual test reveals gross surface defect. Surface, if any defects on the surface, we can identify that defect, like any cracks, any coloration change, any erosion patterns, we can identify by the visual examination. Physical principle is very simple: illumination of test specimen with the light. Equipment used are very simple and portable, only torch and magnifying glass and some limited equipments required for this inspection. Most valuable inspection is NDT tool is human eye. So we can use human eye, or we can identify by the person, if knowledgeable persons are there. So we can identify a lot of damage mechanism in the early stage. Based on that, we can apply the different types of NDT on that section. So mainly performed to obtain general condition of the component. We cannot identify the depth or any other orientation or length of the, measure the dimension of the indications. This is the methodology. Use of optical instrument, magnify defects, permit visual checks for inaccessible areas, foreign objects, formation of layer or even damage, that already discussed. Now suppose these are the applications: inspection of plant components for leakage, misalignment in the equipment parts, corrosion, erosion, crack, fractures. So the limitations are: detect only surface defect and lighting required, and it cannot be exposed to the hazardous place. Suppose we are using indirect technique. So in that we are using cables and lighting arrangements. So if material is exposed to the hazardous place, this equipment has taken a hazardous place, it will damage the equipment or as well as the nearby place. So these are the equipment specification. Various equipment having diameter of probe, different diameter and different length probe used at different applications: steam header inspection, cyclones, turbine inspection, gearbox inspection. So small bore opening also we are having a 3.7 mm diameter probe. So these are the overview of camera visual examination, indirect visual examination cameras, and different diameters and length probes. These are some observations. First observation is in header, we have observed foreign materials, then cracking in second photograph. Third photograph, we have checked the headers of boiler from the tube visible at outside. So we found some deposition, then we cut the end cap, and then we found this mud in this header. And fourth one is a temperature header piping, which is spray nozzle damaged by some force maybe. So that we have recommended for replacement. Then second is dye penetrant test. This technique is used for and only open to surface defect we can identify. Physical principle, it is very easy, capillary action of liquid. So we can use at overhead also, because there is no effect of gravity in this technique. So we can identify the damages at the open to surface defect at overhead portions also. So very cheap method, and equipment required is very less. Penetrant, developer, and killer. Only 3 cans are required if we are doing visible inspection. These are the steps. These basic steps are there. So I will not explain much more on this. Pre-cleaning, application of penetrant, application of developer, then identification of indications. And it's post-cleaning, which is important in the stainless steel case. So this is very much important. This is the beauty of dye penetrant test. We can use combination of the technique and identify the micro level cracks in the system. So first is visible and fluorescent. Then excess penetrant removal. There are a lot of techniques. Lipophilic, which is oil-based emulsifier, generally not used in the conventional type. It is used mostly in aerospace and nuclear industries. Then hydrophilic, which is water-based emulsification, and detergent action taken place, and then excess penetrant can be removed from by water spray. So these are the type of developer. Every developer having different sensitivities like dry, water soluble, water suspendable, and solvent removal. We are generally using solvent removal penetrant. And sensitivity, low to ultra high sensitivity. This is the image of 20 micron crack. So we can identify 20 micron crack also in the dye penetrant test with a combination of different sensitivity techniques. Applications applied on all materials in service testing except porous material. Large surface can be inspected easily with low cost and short time. If you have a large portion, so you can deep the part, and by deeping process, you can do the DPT test on large specimens. A limitation, only open to surface defect can be detected. Pre-cleaning is very critical. Contamination can mask the defect. If any contamination is there on the top portion of the or surface of the part, penetrant will not enter in the defect, and it will not generate the flaws on the surface. Post cleaning is essential to remove the chemicals, because in stainless steel, if chloride or fluoride based elements are there, chemicals are there, it will affect the corrosion properties of the stainless steel. These are some photographs. First is pipe to flange weld joints. Linear indication is there. Then on weld, porosity type indication, rounded indication. Then transverse crack on weld portion. Turbine seating area, there are multiple cracks observed. And then weldolate joint of the piping to header joint. So these are the indication observed in DPT. So now surface and open to surface defect we have discussed. Now if we have defect which is near to the surface, then we are using magnetic particle test. But in magnetic particle test, there is a limitation that we can use only on ferromagnetic material. So a physical principle is magnetic flux leakage. Suppose we magnetize any component. There is a south and north pole available in that component. But if there is a crack like flow, magnetic flux line will leakage, and if we sprinkle the ferromagnetic particle, it will attract the particle and make the defects like this, indications like this. So this is the principle of right hand thumb rule. In on which direction we are using current, we are giving current in opposite side of the opposite side, we will find the magnetic flux. So why I am explaining this? Because I have one case study to explain you. Like this, we already discussed. If magnetic flux leakage is there, we can identify by the same leakage is there if it is perpendicular. If it is transverse direction, it will not detected. Suppose in this headshot method, a blue line is for current pass. If we pass the current in this direction, magnetic field generated in circular direction. So circular direction, perpendicular, if any indication is there, we can detect that indication. Similarly, if we current pass circularly, longitudinal magnetic field will generate, and perpendicular to this longitudinal magnetic field, any defect is there, we can detect. This is one case study. LP turbine of 330 megawatt boiler we have inspected, and by using coil method, we have identified the longitudinal direction crack, which is length leading as well as trailing edge, 30 mm length to 44 mm length. So it is very much important in the magnetic particle testing, the direction of magnetic field, because a direction of magnetic field, perpendicular direction, only we can identify the indications. So this is what about magnetic particle testing. Demagnetization also there, continuous and residual mode. 8000 ampere demagnetization equipment is using. This requires special equipment that works opposite way of the magnetization equipment. So whenever equipment is magnetized in the turbine section, we can use this technique for demagnetization. Now the applications, ferromagnetic material only, perpendicular direction is very much important, and sensitivity also depend on type of current. If we are using AC current, it will give only skin effect, and if we are using DC current, it will go up to certain depth to identify the crack. So it will not use in non-magnetic substance like copper, aluminum. Avoid local heating and burning of substance. Magnetization is important after performing the test. So these are some indications photograph we observed in magnetic particle, visible as well as fluorescent. The first line is for visible inspection, and second you can see the indication observed in fluorescent magnetic particle inspection. These are one sample of hook fluorescent magnetic particles. We found some indications. Now, open to surface and surface defect we have discussed, but now if the defect that is beneath the surface, this ultrasonic testing is used. High frequency 20,000 megahertz, 20,000 hertz to 25 megahertz frequency we can use. Physical principle is acoustic impedance mismatch. Whenever air gap is there, because of density difference, ultrasound will not transform, and it will reflect back, and it will detect in the CRT screen. So very basic instrument available for ultrasonic inspection, and we can cover all these defects like lack of fusion, toe crack, root crack by the use of different types of probes like 45, 60 and 70. To cover the entire volume, we can use different types of probe. This is case study. Circumferential seam pressure vessel. We have found multiple indication that when they open out the weld, we identify the cracks or lack of fusion type of defect. You can see in the picture right hand side. Application, almost all materials can be inspected. Testing can be carried out from one surface. If only one surface access available, we can do the testing. At a time, very large section thickness can be evaluated. Limitations are there. Test method is operator dependent, need highly skilled operator because there is no recording system available in conventional UT technique. Nowadays, PAUT is available, which is a recordable system. This is also a very popular method. X-ray and gamma rays are used, and density difference, because of density difference, which is observed in the photographic film. And whenever density difference is there, cracks or any air gap is there, these indications are observed in the metallic film, photographic film as a dark portion. These are some applications. This is very well-known technique, but limitations are there. Object must be available for both sides because we have to place the film at another side and source at another side. So both side access is required. Skill operator required. Operator training, very much skill required. Field inspection of thick section can be time consuming because we have to give more radiation and possible hazards for radiation to the personnel. These are some photographs. First is incomplete or lack of penetration. We can see the dark line middle of the weld. Then interpass leg inclusions, which is visible at dark in section. Then cluster porosity, lack of sidewall fusion, dark line you can see near the weld. Then elongated slag, burn through. Then offset mismatch and excessive penetration, which is visible as very much bright spot because density is there more in excess penetration. These are the transverse crack and left hand side root undercut, visible dark line on parent metal side. These are tungsten inclusion. Because of heavy density of tungsten, it will appear in the film very bright spot and root aligned porosity. So from this, we can say that criteria for choosing NDT techniques, which is depend on type of material, whether it is ferromagnetic, magnetic, whether it is porous, non-porous, then type of defect, which defect we are looking for, volumetric, then linear, then size and shape of the object, which size and shape of object we are looking for, environmental condition. If there is a hazard place, we cannot use radiography testing, that we have to use PAUT or UT technique. Precision and sensitivity requirement, if we are looking for sensitive cracks, we are using sensitive techniques. And if we are looking for very minor fine cracks, we see in the DPT test, open to surface defect, we can detect 20 micron cracks also. So condition for effective non-destructive testing, product must be testable, approved procedure must be followed, otherwise maybe some defect, maybe chance to miss. Equipment is properly used, properly operating, because cables are there, probes are there. If there are cables and malfunction in probes, equipment not working properly. Documentation is complete after testing. We have to prepare the report. So documentation is requirement very much complete. Otherwise, it will go for the false repair call. And persons are qualified. This is very much important. Now moving towards advanced technology. In conventional UT, we are using different type of probes to cover full volume. But in PAUT technology, we can electronically swipe the beam at different angle from 45 to 75 in one shot only. So we can identify the defect in a recordable base. We have to make the scan plan. Based on scan plan, we can cover the full volume of the weld. And then this is the defect we have observed in UT. You can see the lack of sidewall fusion. It will detect in sectorial mode, as well as it will visible in A scan as well as in C scan. So this is the 45° to 75° angle wide coverage. So with one scan, we can cover entire full volume weld, and this is the recordable technique. This picture is a very beautiful and which is shown the concept of UT and PAUT. In UT, if we have to catch the defect in all the direction, we have to use different type of probe. If one probe, we can identify on the one defect, but in PAUT, you can see all defect in all orientation we can identify and analyze. Then magnetic flux leakage technique is most widely used to detect internal or external corrosion. MFL used array of MFL detectors by strong magnet. This technology generally used in tank floor bottom scanning, fast scanning, because tanks length and diameter very much higher side. So we can detect the corrosion from ID side as well as OD side from the by this technique. Abnormality on the plate wall such as corrosion pit results in magnetic flux leakage near the plate surface. That defect will be detected by the Hall effect probe mounted on the MFL detector. So magnetic particle testing principle similar like this, but the instrumentation is different. This is the MFL scanner. We can prepare the entire tank bottom drawing in this scanner, as well as we can detect and identify the corrosion and pits in this section. Then very much used heat exchanger tubes are very much critical and used in the all petrochemical power plants and fertilizers. And generally observed defects are pitting, wall loss, holes, metal loss at baffle and tube interface, circumference and longitudinal cracks, scaling deposition and blockages. So to detect this, we have technology available, which is eddy current test, in which we have to give alternating current to the coil. If we give the alternating current to the coil and we go to the conductive material, it will create a eddy current in the conductive material. So that eddy current having also magnetic field that is opposed to the original magnetic field. So by the change in impedance of the coil, we can identify the defects observed in the tube. So this is the principle of eddy current. So eddy current technology suitable for non-magnetic material, SS 304, 316, brass, titanium, aluminum. It can detect pitting, corrosion, erosion. Multiple frequencies used for better analysis and flow sizing. And fill factor is very much important to cover entire thickness of the tube. Very fast techniques, 2 meters per second pulling speed. See, this is the case study. We can identify a pinhole of 1 mm by the reference set at 1.7 mm. But still we identify the 1 mm hole. So this is the baffle wall signals, and this is strip chart, and this is impedance plane diagram. So whatever defect is there, we can identify by the angle and voltage of set in the equipment. This is ultrasonic based iris testing, again tube inspection technique. Immersion technique is used in this technology. Ferrous and non-ferrous metal, it is suitable, and it will give entire tube thickness in the result output. So these are the pitting damage detected by the iris technology. So we have only defined 2 techniques in this webinar, because all techniques we cannot define in 1 hour lecture. So there are other techniques also, like RFET, which is used for non-ferromagnetic material, NFT, MFL, and saturated eddy current test. So different techniques having different advantage and disadvantages. So by this diagram, you can identify which technology is used for which type of damage we have in the exchanger. This is a very advanced technique, acoustic emission. When the material is undergoing plastic deformation or crack propagation, acoustic waves are generated. These acoustic waves are in the range of 20 kilohertz. So when a material is undergoing plastic deformation or crack propagation, acoustic waves are generated. That acoustic waves are catched by the different sensors mounted on the component. So this to detect these active flows, we have to mount the sensor on the entire pressure vessel, and we can do the testing of entire component in one shot. This is the principal related slide. A falling tree produces noise, which one can hear. So this sound can hear by the sensors. So it is highly sensitive material, early and rapid detection of defect, flow, cracks, real-time monitoring, then minimizing of plant downtime for the inspection, no need for scanning of the whole structure surface. We can mount the sensors and check the entire component in one shot. Advantage of AET use fast complete volumetric inspection using multiple sensors. If we use multiple sensors, we can do testing in one shot. These are the acoustic emission sensors having pre-amplified, then data acquisition unit, magnetic holders, and connecting cables. These are some experimental data. I will show you the slides. Crack detection. There are different responses there and different activities you can see in the TR diagram. For corrosion detection, there is a different pattern is there, and different activities are there in the corrosion detection. Then this is lead break, because crack at one location crack is there, then it will reduce the amplitude. So this is, apart from that technologies, we have another technologies also there, advanced technique like eddy current array, which is having flexible probes. You can use the eddy current test and identify the entire surface by surface defect. If any having surface defect, we can identify by the eddy current array. Then in UT, phased array ultrasonic testing and POFD is there. Then infrared thermography is there. Leak testing also available. In there is leak testing. There are also techniques are there like bubble leak test, vacuum box test, helium leak test, etc. So this is very important slide, imperfection versus type of NDT methods. So what we have discussed in entire session, techniques having different advantages and limitations. So by section 5, by the table A1.110, they have mentioned that which technology and which type of defect is suitable for which type of NDT. Suppose if circle is there and dot is there, all or most standard techniques will detect this imperfection under all and most conditions. But in this case, in some techniques, may chance to miss the defect. So it is very difficult, as I mentioned, very difficult to cover entire NDT techniques in 1 hour session, because this is the code requirement. We have some requirements of training hours. Suppose we are discuss about UT test, it will require 40 plus 40, 80 hours training, means 10-day training and experience requirement. So if anyone more interested in this, we have a training session available in upcoming month. So you can register on our website and come for learning that NDT techniques. So this is what I have for this webinar. So now the session is open for question and answer if you have. Thank you.
Hello everyone. If anyone has any questions, you can ask.
Yeah, sir. I'm Nirban
Type
from.
your questions in the chat box.
Yeah.
Okay, so Nikhil sir, there is one question we have received. What is the difference between A, B, and C scan?
Yes, okay. So A scan is a it will give the information about depth and amplitude. We can identify only, I will show you the slide.
Okay.
The screen is visible.
Yes, of course.
See, this A scan having amplitude versus time. That is, time is based on, we can say, thickness. So whenever ultrasound reflect back, it will reflect from that location and give us amplitude. So it will give us amplitude versus time. So we will get indication on the screen. B scan is a side view. Suppose this is a weld portion, we can see this one is the side view. So B scan is this. We can check in the PAUD technology. This is sectorial scan. If you start from this location, it is 45 degree, then 46, 7, 8, 9, 10, up to 70 degree. This is sectorial scan. And this is the C scan, top view. In C scan, we can see the top view. I hope it's clear.
Thank you so much for the information. Here we have received another question. What is the best method to check the most correct result for pipe thickness under insulation online mode?
So yes, this we have not covered, but pulse eddy current test is available for this technology, pulse eddy current testing. We can identify the thickness on pulse eddy current testing without removal the insulation.
Okay. Thank you, everyone. If anyone has any other questions, okay, so we have received one more question. For storage tanks bottom, how effective AE is?
Can you please repeat?
Yeah, sure. For storage tanks bottom, how effective AE is?
Ketan sir, can you please explain this answer? Yes, sir. Voice is coming. How effective is acoustic emission testing for tank floor bottom scanning?
His voice is not audible to us. Nikhil sir, Ketan sir voice is not audible.
Yes, sir. Voice is coming.
Nikhil sir, Ketan sir voice is not audible here on Zoom.
Wait. Your voice is not audible from that location.
Okay.
So,
Yeah, basically, the acoustic emission testing is a technique where it has certain advantages over the conventional technique. Number one is that it can inspect the entire equipment in one go. And what I mean by that is that the equipment as a whole contains parent metal and weld joints. Weld joints are butt weld joints. Those joints like which are insulation support ring to shell joints, those are never inspected, right? So those are all covered under the one roof and one single test in acoustic emission testing. That is first advantage, whether it is a tank inspection or any pressure vessel equipment. Both are same. Second is that in conventional NDT, whatever flaw that we find, now there comes a question whether this is acceptable or not. Generally, we evaluate as per ASME code cases, and those are the code cases which are applicable for the fabrication and not for in service. So we go for API 579 evaluation, and that requires very high level of characterization of the flaw. Now, those type of flaws which are very critical may get accepted by API 579, but what is the criticality is governed by acoustic emission very effectively, because in acoustic emission, those flaws which are active can only be detected. Passive flaws are not detected, and that is the biggest advantage of acoustic emission testing. So that is another advantage. There are certain limitations for acoustic emission testing, and those are limited with respect to the skill set, the equipment which is used, number of channels that we deploy, and certain interpretation part. Okay, so those are the high skill areas where we need good confidence into the system as well, from both ends, from the person who is interpreting and from the end user. Coming to your question that tank bottom plate inspection. Now there are techniques like MFL. Then you have to empty down the tank and go inside and do the testing. In service inspection, if you want to do, then acoustic emission testing is the right choice. It can be done with two approaches. One is that you stimulate the tank by increasing the height, that is by increasing the overall pressure on the bottom of the plate by the same fluid which you are storing. And the other way is that you do the water fill test. Okay, if it is at a higher density, then we fill the water test and then do the inspection. So in both the cases, the corrosion is there or some minor cracking which occurs because of the corrosion can be detected by acoustic emission testing in one go. So it is more effective.
Thank you so much for the information. Here we have received another question. What is the correctness of the results of pulsed eddy currents? Can you please share your feedback?
As far as our experience, there is no issue in sensitivity and correctness of the result. The result is correct. Thickness measurement.
What exactly do you mean by correctness of the result? Because if we go for the eddy current testing of heat exchanger tubes, for example, and if we find the flaw which is less than 10%, it is not detected or it is not neither reported. What is the flaw? Flaw is volumetry. It is like pitting or it is like wall loss, either from ID side or OD side. That is what we can detect. But we cannot detect cracks in eddy current, in conventional eddy current testing. If it is like array eddy current, there are certain high sensitivities involved into that, and we can predict that. So going with ECT, the correctness has not a question. There are certain limitations where you cannot detect more than less than 10% of the volume which is being checked.
Okay, so Ketan sir, in reference to the above question of AE, there is one more addition. Like, is there any non-intrusive inspection of tanks which are in place in India other than AE?
Other than AE, basic intention is to find out the integrity of the tank. So other than AE, very obvious thing is visual inspection. we go for visual inspection, is non-intrusive. We find anything on outer surface. If everything is okay, it's fine. We can continue using it. Next thing is that you check for the thickness measurement. It's also kind of a non-intrusive because we can check it from outside only. But that is possible only on the shell and the roof portion. And that can also give us fairly good idea. The only trouble comes when there is a problem on the bottom or the floor of the tank. And if it is leaking, there is a major problem to identify the leak and then reason for the leak. So non-intrusive testing like acoustic emission will help in that case to identify or locate where it is or where are the leaks. There are no other techniques like thermography, but you can't detect anything for the bottom of this floor for thermography. These are certain techniques, and there are all techniques which are having limitations, as we understand. Acoustic emission is one that can locate the flaw, non-intrusive.
Much for the information. And lastly, I would like to answer for Mr. Shriram. He is asked for the recording of this webinar. So definitely, Mr. Shriram, you will get the recording of this webinar after some time, maybe tomorrow or after that, on our YouTube channel. So for the recording, you can please see our YouTube channel. There you will get the recording. And lastly, I would like to thank for both of the speaker and participants. Thank you so much to joining us, and have a good day. Thank you.
Thank you all.
Thank you.